everybody, and welcome to another episode of vBrownBag, the weekly IT video podcast where we bring you experts in the wide world of technology to talk about their favorite topics, kind of like a nerd show and tell, where we get together with our good friends and ask some questions about the cloud, about DevOps, about infrastructure as code, all the fun things. This evening, we have got, all right, hold on, you ready for this? Building loosely coupled and scalable backends using AWS Serverless with Lakindu Hewawasam. How'd I do?
You did really well for the first time.
Awesome. All right. We are off to a strong start. So welcome to the show, Lakindu. It's nice to see you.
Awesome. Hi, welcome. It's nice to be here so early in the morning.
Yeah. So Lakindu is coming from Sri Lanka. Fun fact, he is the brother of Lakindu Hewawasam, who presented for us 3 weeks ago. And they both decided to get up early and do a presentation for us. So thanks for getting up early. And yeah. I'm going to say, I think this is probably the longest distance presentations by brothers ever on vBrownBag. So awesome. We're excited to have you here tonight. Before we get started, let's get a couple of show notes out of the way. If you are in the audience, feel free to get in on the conversation. If you want to @vBrownBag, I will be paying attention on Twitter. If you want to hashtag vBrownBag, I'll be paying attention on Twitter. We are also present on Mastodon. If you @vBrownBag @fastodon.org, we are present there as well. And if you are watching the other channels, there is the Brazil, the Latin America, and the EMEA channels as well. So if you want to follow Lakindu, he is Lakindu Hewa at Twitter. I encourage you to do that. He's an AWS community builder and he's big in the serverless space. And we're very excited to see this presentation. I discourage you from following me, but if you want to, you can also follow me @Mistwire. So with that, Lakindu, I am going to stop sharing and give you the power. Are you ready?
All right, yeah, awesome. So I'll just start sharing from my end. Let me see how to do it. All right. All right, let me know if y'all can see my screen.
We can see your screen.
Okay, how do I get this out of the way? Okay, that will be a Zoom thing. Okay, I'll just leave it.
There you go.
So, all right, now am I on the presentation wheel then?
Yes, the presentation is the main screen.
All right,
building Scalable.
All right, awesome. All right, so good morning, good evening from wherever you guys are. So I'm Lakindu, and today we are going to be talking about an interesting topic, which is building scalable and loosely coupled backends with AWS Serverless. So I just dated it 2nd of February because it's currently the 2nd. So where you may are, the date may differ. So for Chris, it might be the 1st of Feb still. So yeah, so I'm just saying that right out there. It's not a typo, it's just the date from wherever you are right now.
You are presenting to us from the future. This is amazing.
So exactly, I'm from the future. I just watched Back to the Future and right where I am right now. So before we get started, I just want to give a brief introduction about myself. So I am a software engineer currently at Enlear, and I'm also one of the co-founders of a startup called WriterGate, where we focus on redefining content management and content creation. And I'm an AWS community builder. And in my free time, I like to create technical content and write and vlog on YouTube, just all technical stuff. And occasionally contribute on Stack Overflow as well on areas like AWS, Node, Angular, React, and so on and so forth. So yeah, now that we have that out of the way, let's just talk about what we're going to be covering. So this is essentially, so if I were to put this session in perspective, so this would be a perspective of someone who's getting started or someone who has an idea on serverless, but not so much. Because I feel like even though most countries have adopted serverless, there are still people or companies that are still getting started on this shift to serverless from containerized applications or from on-prem servers. So they are just starting that shift. So I feel like this session would get them into perspective on what not to do and what to do instead. So because of that, we're going to be talking about serverless in general and the shift. Why is it such a big hype? And what are the problems that you may face when you first, so as a beginner, as someone who's migrating the infrastructure, what kind of a problem that you might face? So what kind of decisions or what kind of bad decisions that you might take? And what are some good ways to model it instead? So mainly when you talk about serverless, serverless has been evolved to as this cloud, a form of cloud service, cloud computing executional model where these where developers can initially provision and let the cloud provider provision and manage their resources on an on-demand basis. So when we talk about on-demand, it's essentially you have it when you need it. So you don't have to worry about taking care of the server, taking care of the server updates, or the infrastructure that is running behind it. All you have to do is worry about your business logic or your business needs and just focus on fulfilling your business needs. So that's essentially one part of serverless, not just as you can define it in a whole other way, which we'll be talking about in the next slide. And when you're moving to AWS in general, AWS is one of the very first cloud vendors to move into this serverless mindset where they introduced AWS Lambda, which is essentially a compute service, which allows you to run business logic or any code on the cloud for no server provisioning cost or no any management cost. So when you talk about serverless again, it all depends on these four factors, in my opinion. You can consider anything as serverless if there are no servers to provision or manage. So this does not mean that there are no servers. I mean, there's still servers going on somewhere, but they're just abstracted from you. So you don't have to worry about, hey, did I get the right OS on my server? So the cloud vendor takes care of this. And if you have on-demand scalability. So on-demand scalability is where you think about, you want to have, today you're going to be serving 100 users and tomorrow you're going to be serving 1 million users. So to handle that kind of capacity, serverless will help you a lot because it has the capability to scale up, down, and in and out as well. So giving you all the performance that you need. And if you want something which is highly available, so generally when you talk about availability, you would need to consider multi-region deployments, so consider having backups or something like that. So by default, all AWS services or AWS serverless services are highly available, where each of these services run on multiple regions or multiple availability zones with followers, and you never pay for either. So this is one of the best points of serverless, where you pay for just the how do you call it, the resources that you can, or the computes that you use, not just for the time you provision, not just for the entire provisional period. You only pay for the resources that you consume. So for instance, if it is DynamoDB, you wouldn't consume for the server that you provision. You would essentially consume for the resources or the throughput that you consume. And Lambda, it would just be the executional time. So how long your function executed. So in that way, serverless brings about a lot of advantages on the terms of cost, availability, scalability, and reliability, and even just developer efficiency as well into the spectrum. So, but when you talk about scalability in general now, people might think that, oh, just because I have serverless, I can scale my infrastructure, my application to an infinite level. But the thing is, you have to understand that scalability will come at the cost of how you model your application, how you model your backend API. It's not just like you have a single Lambda function having all your requests, so that won't be scalable in the future. So likewise, you have to think about how you are going to be modeling your application in order for it to bring out the scalability that you need. So these are some of the common mistakes that I have seen when people have jumped right into serverless. So one thing is a Lambda Monolith, synchronous invocations, and Lambda chaining. So we'll take a look at this in depth in the next slide. So a Lambda Monolith is what I've seen is what people do when they mostly migrate onto a serverless stack. They just think that, okay, I have one Lambda function. So in a monolith, I had all my code base in one. So why don't I just chunk it on into one big Lambda function and just let that handle everything via an API gateway. So yeah, so that's okay. Okay, I thought, okay. Can you hear me? I mean, is my audio breaking up?
There every now and then there's like a little bit of a stutter, but we can understand you and you're coming through fine for the most part.
Okay, give me a second and I'll just open my door a bit. I think that might be the issue. Give me a second.
Okay, sure.
Okay. I think I can run somewhere. Okay, so let's just see how that works out. Okay, so back to the session. So we're talking one monolith. So Lambda monolith. So people who would all my code based on this big monolith, why don't I just chunk it in one Lambda function and just see how it does? So this is one really bad practice. Even AWS highly discourages it because it handles. So when you have all of your application code, one thing is in terms of readability, your code would not be readable at all. That's just from the development perspective. And when you talk about same role, that would have essentially a huge number of access and create, and even you would essentially give one role access to entire application. So if that role gets compromised, you can say bye-bye to your resources if one hacker or somebody gets access to your role there. So you have entire application access to S3, DynamoDB, Cognito, or anything that you might have in a serverless ecosystem. And the next part is you would likely hit the scaling limits from AWS Lambda, because so AWS Lambda, the default concurrency limit would be 1,000 at any given time. And if you have any burst invocations, it would be close to about 3,000 invocations of burst concurrency. That is, again, depending on the region you deployed it. So with this, what happens is after these limits start to hit, Lambda will start to scale linearly. So linearly is like when one operation or when one API request finishes, it starts to process the next one. It doesn't scale, it doesn't execute these requests concurrently. So that means you're likely to hit some kind of performance latency, or you're going to just get your request throttled because Lambda is having too much demand on that single Lambda function. It can't distribute the load. And because of that, you might have really big bottlenecks, and it might not scale well when you think about your application in the long run. And the second one would be synchronous invocations. So synchronous invocations are essentially stuff that you could just offshore and stuff that are related, but you could just offshore it and not execute it one after the other. So for example, is I've seen many people I've seen many people all across Sri Lanka, for example, when they implement something like S3, they would ideally use it to store some images of some people, so their profile photos maybe. But what I've seen they do is they would essentially take this item onto S3 and they would put it, and then in that same Lambda function, they would ideally create the thumb and put it onto another S3 bucket, or they would have that S3 URL return on that Lambda function synchronously, and they would persist that onto DynamoDB. So this is the kind of sequence diagram that I've seen people do, and this is the exact sequence diagram taken from AWS, but I've seen people implement it. So in these cases, what happens is you're adding unnecessary latency because you don't. The role might be to store the Lambda, to store the in a profile picture, but after that you could process these events in a different way rather than waiting. So ultimately, when you upload about 3 to 4 megabytes into your bucket. So you have to wait until that finishes, and then it returns another response, and you might so this might be extended on to create a thumb, or you might just directly push it. So that adds another latency also. So we will take a look at, you can either, so one good approach on doing this would be you have these S3 since serverless, with serverless you can adopt event-driven architecture. So you can think about what kind of events do you want your application to produce. So for example, when a user puts an image onto S3, I want an event which will trigger and generate a thumb, and then there should be another one which says to store a reference. So with that, you can create these triggers from S3 itself, and then you can process this asynchronously and let it do the job on its own pace rather than you waiting from your front end. So this will again prove to reduce cost also, because this single Lambda function won't be executing for that long period. It won't wait until all these synchronous flows are being executed. So yeah, so this is essentially what I've talked about. It adds latency or response cycle, and it's also very hard to handle errors, because for instance, let's say that you essentially persisted your image onto S3, and then you had another S3 bucket which would then create a thumb. But here what would happen is if the thumb fails in your code base, you'd have to handle that here. The first bucket already has this object, but the second bucket does not. So you have to handle that error handling. If not, you'll be persisting it all over again. So that adds a bit of performance issues, and you might have to add extra code, and it creates solely tightly coupled code. So when you talk about tightly coupled code, is all of these events occur one after the other. So you can isolate this, and you don't have independent fault tolerance here as well. But even if that's when you do it in a single call. And when you talk about from a service limit standpoint, again, you might hit the API gateway maximum timeout. If you're executing through API gateway, you'd have a maximum of 29 seconds within the API gateway from a Lambda. So you might hit that timeout. If your file is about 1 GB, 2 GB something, if you're performing that synchronously. And you might also be hitting a Lambda timeout, which is a maximum 50 minutes, but that's very unlikely unless I'm not sure what you're going to be uploading in that. So that's just a fun fact for you all to know. I doubt you'll be hitting 50 minutes because I've never hit a 50 limit still. And again, the concurrency limits. So yeah, so that's another kind of common issue that I've seen people run into when they try to adopt serverless in Sri Lanka, or just in general, if you are trying to adopt it, try not to make this mistake. And the third one is Lambda calling another function. So this is Lambda chaining. I would call it Lambda chaining. So again, this is another form of synchronous invocation where you call, someone might assume that's okay. Here, what happened was you had in the previous example, what you had was you chained your Lambda functions, you change your operations in your Lambda function, but they might be like, okay, why don't I introduce separate Lambda functions? Now, single responsibility, I can just assign a dead letter queue onto each Lambda if it fails, and push that onto a DL queue where I can handle the errors. But then they might be wondering, okay, now I have independent fault isolation, and because they're in 3 Lambda functions, they might have 3 different concurrency executions. So yeah, then that might be good. But again, you might notice that this again follows the same synchronous invocation where you invoke this Lambda function and then it goes to this second Lambda, and that invokes the third one, and then you have to wait until this second Lambda function finishes its execution before it returns back to the first one. So again, this is a form of chaining invocations. And again, that's your initial drawback, which is you scale these Lambda functions linearly, where it happens request after request. You don't allow them to scale independently. So that means when you have 1,000 requests, all of these 1,000 requests will go in a linear manner. So that means, again, you're bound to face the same issues that you're facing here. Again, you might have another concurrency limit issue here. And you're also coupling your Lambdas against each other. So what I mean by here is you're depending on the operations of a previous one, and you're waiting until they execute. So you don't have, again, you're trying to build up a sequential flow rather than processing these asynchronously. And again, if I can go back to the previous slide here, okay, that's just keynotes, just remind me there. So if you just go back to this slide here, you might notice that this first Lambda function overall has the lowest or the longest response time. It has to wait until both the subsequent Lambda functions finish its operation. And if you extend that, you might have a really big response time or really big wait time on the first Lambda function. So that's again another big drawback, because the end user would still be waiting for the response, where you could have, like, once you process the payment, you could push an event and then you can return it. And that kind of stuff, where you create the PDF and then you email the PDF to the user, that can be done in a synchronous manner where the system takes its own time and to scale and does not get a bombarded amount of requests. So for that, you should understand that building serverless API. So I threw a few buzzwords here and there. So I talked about having queues and events and all of that buzzwords over there. So you should understand that with AWS, so with any ecosystem in general, with any cloud vendor in general, serverless is not just about a cloud function. It's so much more that people just don't seem to understand when they first adopt it. They're like, okay, I'm using AWS Lambda, I'm on the serverless ecosystem right now. But no, you can have a lot more. Serverless is not just a Lambda function. And there's a lot more stuff that you can do with AWS Serverless. So for instance, you can try to avoid doing this synchronous invocation that we have seen in the start, and rather focus on building asynchronous architectures where applicable. So for the first one, this is a nice design pattern called queue-based load leveling. So it's not a design pattern, it's more like an architectural pattern where you can use queues to distribute your load and decouple these systems. So one good service that AWS has is SQS. So SQS is just a serverless queue, which is used to help decouple distributed systems, and it helps you integrate these systems together while passing messages. And these queues allow its consumers to scale independently while having its providers give it any number of subsequent requests, and these queues can determine how its consumers scale. So this is really good when you have these asynchronous flows and you want to build these distributed and when you have synchronous flows and you want to build these asynchronous operations. And you essentially help device execution. So you might have a consumer which builds these PDFs, and the front end might be sending about 1,000 requests. You might have 1,000 users building the same PDF, building a PDF somewhere in your system. So you might push this onto a queue, and you might tell the queue lambda or queue generator lambda, hey, you can take your own time and build this PDF. I won't push these requests on you immediately. I'll just give it to you at a time. You can have it at about 30 seconds or 5 seconds per iteration, or every 5 seconds I'll give you some records. So you can just set that to the queue and the queue will take care of that. So for instance, this is one good architecture that you can build for. So if you have, let's say, you are building a scraper service on your front end where you give some URLs and your 100 URLs, and you want to scrape these URLs and build like a portfolio for your application. So what you would ideally do is, rather than having one forward-facing Lambda from an API gateway, where it takes in these URLs, visits these URLs at a time, and then fetches the data, and then compiles it. So that would be really time-consuming because it all depends on the network and how these systems from the other side are doing. If they are performing very slow on their servers, you might have to wait a longer time. So in operations like this, you could have like an SQS queue where you push all of these URLs onto the queue and pass it onto the Lambda function. So the Lambdas or the consumers who consume these messages from the queue would ideally poll these messages and process them independently. And when you use SQS with Lambda has the ability to scale up to 60 instances per minute. So that's also quite reassuring for you. And SQS also supports up to 10,000 messages where you can batch these messages. And you can also have fault tolerance. So what do you mean by fault tolerance? So let's say one of these records that you have in the queue runs into an error. So you can set a retry period. So I'll give you the message. So the consumer will receive the message for this amount of times, for this number of times. And after that, it will be like, hey, this is continuously falling into an error. What should I do now? So then you can be like, put this into the letter queue until we can find out what the exact error is. And then once we fix the error, we don't lose the record. We just start a BLQ redrive, and that will push the message back to the queue, and then it will again start being processed after the errors have been fixed. So you might notice why I have a DynamoDB table here. So let's say that the client, so this is just one approach. You can achieve this using WebSockets also, but this is just one simple approach to get you started. So let's say that you take this 50 URLs and you have a Lambda, but the client still has to know what the status of each of these polling is. So how are they scraping going? Did it run into an error? Did it finish? How did it go? So for that, one simple approach that I've seen people do is you can process this in a forward-facing Lambda in an API gateway, and then for each of these URLs, you could assign a unique identifier, and then along with an initial status. So initial status could be like pending, and then you persist that record with the ID and the status and the URL onto DynamoDB, and then you push that exact record onto the SQS queue. And from the queue, you would take that and then you would process it. And the client would have another Lambda, which could ideally maybe poll the API gateway and see what's the status of these URLs. So that's just one implementation. You could do that using WebSockets as well. And then inside these consumer Lambdas from the queue, they could process this, and they could ideally set a status. So complete, or they could have like a progress indicator or something like that. And the front end could poll that and react accordingly. So that way you keep the consumer informed while letting the system take its own time to fetch these records from these several websites. So yeah, that's what I mean by process your messages at own pace, allowing to preserve scaling limits. So you don't scale linearly here. You don't be like, hey, 50 requests came, I'm going to send this one by one to you. That's not going to happen. So SQS will take the records and it will give it at the pace that you define. So you can have like delay seconds. So you can have like a delay second. So delay seconds is within every period you push the records, how long should the other record wait? So that's good if you know that your record will take about 30 seconds and there's no point giving it more records, because that just add on to more piled up concurrence execution limits. And then you can consider the batch size when you consider your queue. So batch size is essentially how many records should I give per consumer. So that's also a good tip if you want to have like parallel processing or batching. And then the retention period. So retention period is very helpful, that if you have these very long running executions in the queue, how long should you keep these messages in the queue for? So that's also quite helpful. So generally, I would usually keep the records in the queue for as long as they are needed. Which, by default, I think you can go up to about 14 days in the SQS queue, but you can change this depending on your requirements. So that's one practice that you can do. This is queue-based load leveling. And then another approach is fanning out. So fanning out is, I'm pretty sure many serverless people know what fanning out means, but for those of you who don't know, we'll just go through it again. So fanning out is more like you have one producer or one topic or one owner, we could call it an owner, and then it allows you to push on to different resources, different consumers. So allows you to fan out and spread your load. So with Amazon, you can have something called SNS, which is quite used for this fanning out kind of implementation, where you have several different, you use the same event payload, but for different purposes. So for example, you might have an API gateway again, and you might have an SNS topic. So SNS is essentially simple notification service, which works on a pub sub basis. So this works on the pub sub architecture. And you can have different consumers where you take the same payload and do different things. So for example, you might have a notification Lambda here, and then it processes, pushes it onto a topic. And from where you need to send an email, you need to send an SMS through Twilio or something, and then you want to push it on to another Lambda function where it begins its own separate execution to generate a PDF or something. So if you take a look at this, these three operations are not tied to each other independently. Though they perform one part of the application, they perform some kind of notification, they are not necessarily coupled to each other. So what I have seen is, or even I have made the same mistake when I started out. What I did was, I had the same use case. First, you have like an in-app notification count, and then you email it. So what I did was, I had it all in one Lambda. So that was a really bad practice. And I noticed it after I learned about this practices and what not to do was, so for example, you can't isolate fault tolerance here. So in my Lambda function, the case was I had the notification count that was counting for in-app notifications. And apart from that, I was also having an email service. So sometimes the email service would fail from the third party. And because of that, the entire Lambda would fail and get started off again. So that meant the notification count would be doubled or tripled based on the error rates. Because SNS offers by default an automatic error retry of 3 times, I would ideally have 3 times the amount of unread notifications. So that was a really bad practice, because this last service failed. So like I said, you don't have fault tolerance per operation if you couple your operations together. You would have to implement that on your code level. And this fire and forget implementation. So right now, I think now you can have dead letter queues also on SNS. I'm not too sure about that. Maybe something happened at reinvent that I missed out on. But you could generally, SNS, since it works on a fire and forget kind of implementation, you would ideally lose your messages after this error retry unless you specifically handle this and say so. So how this would work is, your Lambdas or your consumers would get these messages or these events, and Lambda is not the only thing. You can push it onto different kind of services also, and they would process it independently. Again, you would allow your Twilio Lambda to scale independently, your SendGrid or any other notification service, or your SCS, you might allow that to scale. These Lambdas, these operations, you would allow them to scale independently, thus reducing the load on each Lambda. And you might notice that when you have an kind of these event-driven architectures, the consumer does not know who the producer is. They just know, okay, an event occurred, I should react. So in a way that you completely decouple or loosely couple your services also. So in a way, it also helps maintain, because these consumers are not aware of who's giving, so it's easier to maintain in a way. And finally, you might have the best of both worlds, which is topic queue chaining. So topic queue chaining is another pattern. It's a combination of the two patterns essentially. So topic queue chaining is like, you might have the same operation. So let's say you need an SNS topic, but you also want these Lambda functions to scale on its own pace. Now, because SNS fires and forgets, it immediately pushes the notification. That's used for instant real-time notifications. It immediately fires. So again, if you have 1,000 notifications pushing into your topic, it would emit 1,000, again, it would emit 1,000 pushes. That means all your Lambda functions will again be exhausted again. So one good way to avoid this is you have an intermediary queue chain here. So essentially that's why it's called topic queue chaining. You have a topic that pushes the messages, but they don't push it onto a Lambda or another AWS service. They would ideally push it onto a queue. So again, the stuff we learned before from the queue, you can control how the end consumers get the message, or at how many times per second, or after how long it should get another message. You can control all of that. And even you can control the Lambda scalability. Recently, with recent introduction from AWS, you can now control how many Lambda functions you need from that to scale up from that queue also. So that's a recent thing that was introduced around few weeks ago, I think, where you can control the Lambda concurrency within an SQS queue also now. So that's also something interesting. Now, what happens here is when you push all of this data onto your queue, you can also, again, have the same benefits from queue-based load leveling, where you have independent scaling of these Lambdas. Rather than pushing it instantly, you can have like a delay period or a visibility timeout, or maybe delay period, I would recommend, where you say after 5 seconds or 10 seconds, you wait, and then you give more records. So yeah, so again, it helps you to decouple or loose decouple your application, but it helps you scale these services again independently without giving a burst load onto your consumers. And you have better fault handling also. You can have a DL queue for each of these SQS queues. And because you might be wondering, I'm provisioning so much infrastructure, why wouldn't I get cost? Again, because it's serverless, you don't get paid for any thing that you have idle. You get only in SQS, you get paid for the events that it was action that it does. So mainly the messages that it has. So yeah, so that's also, you don't have to pay for idle. So that's also good. So with that, you can have a DL queue where it processes these error messages also. So in a way that you have added fault handling also. So that's the best of both worlds. Topic queue chaining. So I recommend doing that for anyone who's getting started and you're building these really complex, time-consuming and high-demanding workloads also. So this is another example where you use, I took it from an AWS workshop where you use topic queue chaining and as a buffering load balancer. So again, you might have the customer who is sending up API requests through an API gateway, and from here you would push it onto topics, and then you push it onto queues, and these queues rather take the records. And so usually data ingestion takes a really big long time. So because of that, you can push it onto a queue rather than immediately firing it onto a consumer. You can push it onto a queue and let the queue give the data. So you can control the rate at each of these consumers get the data. So you don't have to have the same operation, same configuration per queue. You can have different configuration based on the requirements from these consumers. So yeah, that's one good way of modeling such complex and highly distributed applications. And also one thing that I didn't explain with SNS when you use topic queue chaining is with the topics, you can control how many consumers get the data. So for example, if you push something here and you don't want this extraordinary right size to get it, you can simply have these filters. You can set up message filters either on the message body or as message attributes. Because recently, one of the biggest drawbacks with SNS you had was you were not able to do message body filtering. But now SNS offers message body filtering as well. So you can directly filter messages from the message body and be like, if this condition meets, I want you to push this message onto this queue or this Lambda if you're not using any queue. So that's essentially another good way of avoiding a synchronous invocation or Lambda chaining, and you just allow these distributed systems to independently scale without exhausting these limits on each service. Now, there might be times where you exhaust services even though you scale it like this, but that's when you need to take a look at tracing and see how your application performs and what's the issue, what are the issues that you have there. So that brings me on to my final point. You have to be thinking that serverless is not just about having one implementation and thinking like you have infinite scalability. Serverless can offer limitless scalability if you implement it correctly and if you architect it correctly. If you have a very poor implementation of your serverless infrastructure, you will not do well in the future. You might not notice it at a very small scale. For about 50 to 100 users, you might not notice it at all. But if you are serving a mission critical or a very heavy production application, which has about, I don't know, 50, 60,000 users accessing it per minute or per hour, then you might start to notice severe pitfalls in your application. And you might be wondering, I'm telling you about distribute this, distribute that, spread the load and all of that. So you might have a really big architecture there, but always keep in mind that you have to take into account factors like cost also. So all of these Lambda functions and performance also. So Lambda functions still suffer cold starts. So you should ideally consider the sweet spot. I mean, if you, it depends on the runtime again as you use. So recently Lambda in Java was one of the worst performing Lambda functions ever. But recently they introduced Snap Start, where you can have caching on these. I'm not sure how it works. I think there's caching on these instances that they spin up. I think that's how it works. I'm not too sure how it works. But with that, they significantly reduce the call starts on Java. So again, it depends on your need. So I'm telling you, don't just try to implement a very big distributed architecture just because it allows you to scale this service well. There might be pitfalls on its own. With Lambda, you might have cold starts and you might rack up a cost because you might not need certain resources. So in that way, you might have added performance issues also with these cold starts taking into, if you're talking about Lambda per se. And you might also want to consider observability. If you have a very big distributed system, you will have very poor observability if you do not implement it. So if you will need to introduce some kind of an observability tool to keep track of everything that's going on in the system. So usually debugging one Lambda is easier than going through a several Lambda chain, because if you have not used observability, you might have to start from its origination point and then go on CloudWatch, or you might want to use X-Ray. If you want to tracing, if you're into tracing, you might want to use X-Ray. And if you're just into viewing the logs, you might want to open up CloudWatch and go through these logs. So I recommend having an observability tool, or just finding the sweet spot between your scalability, performance, your requirements, and observability. And that way you can determine what you need and what you don't need. And then some stuff that I did not include was with these, so event bridge intelligent routing, I don't think it's quite relevant now, because now with SNS, you have these event intelligent routing, but if you are building a really big distributed application, you might want to consider using event bridge, because it offers you a real time, or it offers you an asynchronous event bus, where you can essentially build distributed applications rather than building distributed parts of your system. You might want to help communicate across applications. So that way you can use event bridge. So you can push messages or dump messages onto an event bridge, and that might be taken by another application to process. And if you are into orchestration and you want to maintain a state function, consider using step functions. And always understand when to use asynchronous and synchronous. Do not use asynchronous for really small applications. So for instance, if you're trying to build a simple GET request from DynamoDB table, don't try to, or a simple post request where you just persist some data onto DynamoDB. That itself offers single digit millisecond or millisecond latency. So that is not something you would need to build in an asynchronous approach. So consider what to build asynchronously and what to build synchronously. So yeah, I think that's all I have to leave you with. And yeah, you all can connect with me on Twitter. And if you want to check out my blog, here's my blog URL on the platform that we've developed. And yeah, here's my LinkedIn if you want to connect with me on LinkedIn. So yeah, that's all I have for the day, Chris. Thank you.
Nice. Wonderful presentation. I find it interesting. So depending upon which types of developers I'm talking with, and I'm not going to say older developers versus younger developers. I'm going to say developers that have been developing in the cloud for a long period of time versus those who have been developing on-prem seem to have a challenge with this, particularly because the challenges that you stated, creating a Lambda with creating a monolith Lambda, developing something where they've jammed everything into one Lambda is something that somebody that has been developing on-prem will do. If they started developing in the cloud and they started developing serverless, they inherently know how to break things apart and how to distribute things. One of the things that they do get challenged with that I find is interesting is alleviating back pressure. Like nobody gets back pressure until they run into it. Then they're like, oh, I should stuff a queue here. Oh, I should put an SNS topic here. Oh, wait, now I have too many. Oh, now and it's this fine balance of getting bit on the butt. It's like building something then it becoming very popular, and then getting bit on the butt when it falls over, and then having to basically re-architect it to alleviate various pain points as you go. And it was interesting the way that you addressed the challenges, because those are exactly from a timeline perspective, those were the challenges faced by people, because they'll break it apart into a larger architecture. They'll create queues to alleviate back pressure, and then monitoring and observability becomes a problem, because then they're starting to like trace down logging and debugging across an entire architecture. So I find that your presentation dealt with the challenges temporally that a developer will face as they're going through an entire project.
Yeah. Thank you for that. Yeah, I mean,
well done.
It's yeah, thank you. I mean, the thing is, I mean, I'm pretty sure that where you are, Chris, I mean that people already know most of this stuff by now. But the thing is, there's still countries that have not yet.
Oh no, this is fantastic stuff for anybody. I mean, anybody that's getting into the space needs to see this over and over and over again. It's never
exactly.
There are large enterprise organizations in America that I will tell them to come watch this. There are tiny little startups that already know this. So
exactly.
This type of knowledge, these types of presentations I really like, because the information isn't something that's going to become stale in 6 months. The people need to know this architecture, and this presentation will be relevant 3 years from now. The technological service availability stuff like snap starts, that's going to change. But
yeah, exactly.
Having something that allows you to get your Javas going faster, your Java runtimes going faster, is going to be necessary, regardless of whether or not snap starts exist in 6 months or not.
Exactly. Yeah. So the thing is, I mean, in Sri Lanka, if you take a look at it here, serverless is not that big here yet. People are still hyping on about it, even though serverless is not that big of a buzzword. I won't call it that big of a buzzword because it's not quite new now. In Sri Lanka, it's still relatively new, because even, for example, even if you ask anyone, most of the people here what they think of serverless, they would either tell you something like Lambda or Cloud Functions, and I'm not sure what Asia has. I think Asia has Cloud Functions. I'm not too sure, but they would either tell you these three Cloud Functions, compute services. That's it. So I think it's important that they know that serverless is not just about, hey, we just have Lambdas or Cloud Functions. We have a lot more than that, and you just have to utilize all those applications to bring out the full power of serverless.
Absolutely, absolutely. And Graham called it in the audience. You learn more when things fail. All of this is foundational, and it will still be relevant in several years. I fully agree with that. Awesome.
Exactly. Let's say. Yeah, when I had that, I learned more when things fail. Like I built my notification service on my own. Yeah, that was the mistake that I made. In a really big mistake. Yeah.
If only there was a place where we could write all of our mistakes down so that other people could learn from them.
Exactly.
How do we do that? Awesome. Yeah. Well, Lakindu, thank you for getting up early in the future for us for this presentation. It was wonderful. Awesome. We will be with you once again, dear listener, 1 week from today for our next presentation. Probably not from Sri Lanka, but we will have to make do with somebody closer by, unfortunately. Cool. Well, Lakindu, awesome. Thank you very much. Have a great day, and thank you for the presentation. This was great stuff.
All right. Thank you for having me, Chris, and I hope to be part of much more vBrownBag talks in the future.
We will absolutely have you on, guaranteed.
All right. Good
Cheers.
night
Bye-bye.
to you. Bye-bye.